Okay. Okay, let's do an example of this type. Right. Okay, I'm going to explain a separate example. Let's find the oxidation state and valency of this nitrogen and this oxygen and this oxygen. Okay. Okay. First, what's the valency and oxidation state of this nitrogen? Okay. We'll put a chart like this. N nitrogen, oxygen, and O minus. This oxygen, that is O minus. Central nitrogen, central oxygen, and nitrogen. Okay. Valency and oxidation state. First, let's find the valency, right? What's the valency of this nitrogen? Okay, same problem. What's the valency of this oxygen? 2. Valency is 2. And for this oxygen, what's the valency? 2. Right? Covalency is 1 and electrovalency also 1. So totally 2. Here 2, both are covalency. And what about here? Nitrogen. Covalency 1, 2, 3, 4. 4 covalent bonds. So covalency is 4. And electrovalency. Electrovalency means what? Magnitude of charge 1 plus. So 1. 1 plus 4. Totally 5. And this is the valency. So how to derive how to find valency? Number of covalent bond plus number of magnitude of charge, right? Whether it may be any charge, positive or negative. Just you should see the magnitude number before this charge, right? Not the sign. And oxidation state, you should consider sign also. What's the oxidation state of this oxygen? This oxygen. Oxidation state of this oxygen. How to find the oxidation state? Yeah. Oxidation state is equal to what? Charge, total charge. 1 minus. 1 minus. And from here, what is the charge? From this side, no charge because same atom. So there is no delta plus delta minus. So the charge is only 1 minus. So the oxidation state is also only 1 minus, minus 1, right? Minus 1, right? Once again, right? Minus 1, right? Why? Simpler. Right? Ionic oxidation state. Ionic oxidation state is minus 1. Covalent oxidation state 0. Why? Same atom. So covalent oxidation state 0. This bond cannot be considered as you can't convert this this bond hypothetically as an ionic bond because these are same atom. The bond is homonuclear bond, so you can't do it, right? And for this middle oxygen, central oxygen, what's the oxidation state of central oxygen? From this side, the oxidation state is, from this side the charge is 0. Why? Same atom. From this side, yeah, different atom. So how many bond? 1 bond. So one atom would get 1 plus and the other would get 1 minus. Which would get plus and minus? Just consider electronegativity. Which one is electronegative? More electronegative. Oxygen or nitrogen? Oxygen is electronegative, so it would get -1 and this one get +1. So the charge is what? Oxygen. What's the charge? -1 again. And here nitrogen. Simply see how many bonds are there? Covalent bond 4. So the charge from that covalent bond would be +4 or -4 or anything, right? For that, what you should see? Electronegativity, right? So oxidation state is what? Charge. What's the charge? Ionic oxidation state is +1. There's a +1 charge, okay? And with that plus, what's the covalent oxidation state? Nitrogen is connected to oxygen. All surrounding atoms are oxygen, okay? Just see how many bonds. How many bonds? 4 bonds. And so nitrogen should get -4 or +4. Right? From this one bond, right here, nitrogen has 1 bond. So nitrogen is +1. Oxygen is -1. Here 2 bond, nitrogen +2, oxygen -2. 1 bond, nitrogen +1, oxygen -1. So totally, what's the charge of nitrogen? +5. Ionic oxidation state +1. Covalent oxidation state +4. So +5. Okay, this is the way you have to do. We'll do one more example. Simple example. SO2. Around sulfur, how many bonds? 4. Okay, but what's the oxidation state from this bond? From this bond, what's the oxidation state? Sulfur +2 or -2, but it's +2. Why? Oxygen is more electronegative. So this one would be -2 and sulfur +2. And consider this one -2 +2. So totally +4. Right? Totally +4. One more example. SOHH. Okay. What's the oxidation state of sulfur? Quickly, can anyone say? What's the oxidation state of sulfur? Quickly. Right? Huh? 0. Yeah, the oxidation state is 0. Why? This bond, right? Sulfur +2, oxygen -2. Because bond is what? How many bond? 2 bond. So one should get +2 and the other should get -2. Sulfur is less electronegative. That means relatively positive. So +2 -2. And from this bond, which one is more electronegative? Sulfur is more electronegative. See, sulfur is more electronegative here. Hydrogen is, sulfur is here, hydrogen is here, right? So what's the charge? 1 bond. So this one is +1 and sulfur is -1. And consider this bond. What? Again, hydrogen +1, sulfur -1. So what's the total oxidation state of sulfur? +2, -1, -1. Totally 0. Oxidation state of sulfur is 0. Okay. You can easily find the oxidation state like this, right? And try this also like that. Okay. So okay, that's all. Note it down.